So in this video, we're going to solve the cosine of x plus 3 pi 2 radian plus the cosine of x minus pi 2 radian is equal to positive 1. And we have to visualize the domain restriction, which is the interval between 0 to 2 pi radian. When we say we want to solve for an expression, that is saying that what are the input or a domain of the x value we have to input to get this expression equal to positive 1. And we always have to remember that according to the property of trigonometry, sine, cosine, and tangent are periodic functions. And they have a lot of or infinite value of domain, which means x value that has the same one output. That's why we need a restriction, and they gave us the restriction as the domain's interval. So we need to solve from 0 to 2 pi radian the x value that satisfies this whole expression as positive 1. So we can approach this question using the two different ways. The first way to solve this is by using the fundamental identity, which we call it as the sum and difference identity. And the second way to solve it is using the transformation of angle rotations in the unit circle. The second one is a little bit more harder, so I'm going to explain how to solve this question using the sum and difference formula in these videos. And after I explain the sum and difference formula, next video you have to check it out to relate it to the sum and difference formula, which one is better for solving this type of question. So before we start solving the question, let's think about what does it look like for applying the sum and difference identity inside the trigonometry. We always have to remember that, and before I start explaining or reviewing, you have to go back to my previous video about what is the sum and difference identity to make sure you can solve this question by applying it. And for sum and difference formula, again, we know there are three types of the special angles: pi over 6 radian, pi over 4 radian, pi over 3 radian, which are 30 degrees, 45 degrees, and 60 degrees respectively. And for example, there are the angle rotation we can't express using the sine, cosine, and tangent easily on the unit circle. And those values are, for example, 15 degrees, 75 degrees, 105 degrees, or on and on. Those are the values we can't express or we can't notate or solve for sine, cosine, and tangent on the unit circle. However, by manipulating those angle rotations on the unit circle using our special angles pi over 6 radian, pi over 4 radian, pi over 3 radian, we can solve for those angle measurements, sine, cosine, and tangent trig values. But the way to do it is we have to pick one of these three special angles, and we have to add not one of them but two of them, and we have to add them or subtract them. We have to add them or subtract them to form the angle measurements to solve the trig values. And this is basically what the sum and difference identities are. And in this case, as we can see, they are adding the two angle measurements, x 3 pi over 2, x, and pi over 2 radian. But just like we talked about in our previous videos, we are dealing with the cosine sum and difference identities. So firstly, before we start any question, we have to review what is the cosine's sum identity first. For sum identities for the cosine, we use cosine and we write two angle measurements, for example, alpha and beta. And we have to remember that the alpha and beta are one of the special angles from pi over 6, pi over 4, and pi over 3 radians, or a multiple of them. And if you say that alpha plus beta, when the two angle measurements are being added to form one angle, that's when we call it as the sum identity. And we're dealing with the sum identity for a cosine. And the reason why we have an identity is because a lot of people might think that, and this is a common mistake, a lot of people might think that we can distribute the cosine. We can distribute the cosine to each angle measurements and create cosine alpha plus cosine beta. But we cannot do it because inside the trigonometry, while we're dealing this type of the identities, we cannot apply our fundamental operations we usually apply for solving or dealing with the real numbers. So that's why we need a special identities or formulas we have to apply. And if you remember, cosine of alpha plus beta, where we add two angle measurements to form one angle, and we're trying to solve for a cosine of that angle, the formula will be equal to, it is cosine of the first angle alpha times the cosine of the second angle beta. And we always have to remember that unlike the sine-sum identity, if you're dealing with the sum identity for a cosine, the mid term will be the subtraction. Subtract by the sine of the first angle alpha times the sine of the second angle beta. And this is what we call the sum identity for the cosine. And we even memorized how to remember those. Cosine alpha, cosine of beta, minus sine of alpha times the sine of beta. And in a previous video, we remember it like this. For any kinds of sum identity or difference identities, such as sine or cosine, we remember it by how it is pronounced. So for a cosine, we usually read it as co. Cosine, we read it as co. For sine, we read it as sin. And also sine, we read it as sin. For angle measurement, we have to remember it because if you're adding the alpha and beta, then the order how the angle is arranged is alpha, beta for any types of sum and difference identities. So remember, we remember the cosine alpha plus beta, sum identity for cosine as sin, and sin. That shows that it is the sum identity for cosine, which is cosine of alpha times the cosine of the beta minus the sine of the first angle times the sine of the second angle. And this is the sum identity for cosine. And the way I memorize it, even though it might look pretty childish at first time, but as we get to solving more difficult or deeper question in trigonometry, if you cannot memorize the identities, we won't be even able to approach those questions. So this was the sum identity for cosine. But I told you guys that we don't have to memorize the difference identity. The reason is because the difference identities, such as this one, cosine, instead of alpha plus beta, we are subtracting the two special angles, alpha, beta, to form one angle measurements, such as alpha minus beta. Then this will be a difference identity since we're dealing with the subtraction between the special angles. Then you will have the exactly same value with cosine of alpha plus beta, except the midterm for a cosine will turn into positive like this. It will be cosine of the first angle times the cosine of the second angle, just like the sum identity for cosine, except when it is negative, when it is a difference identities, then it will be plus sine of the alpha times the sine of beta. This is what we call difference identities for a cosine. And again, we always have to remember this, and the way I memorize for a cosine is how it's pronounced, just like sine, and we remember it as sin, with the angle arrangement alpha, beta always. And if you're not familiar with this concept, you won't be even able to apply these identities to trigonometry, and that means we won't be able to solve any questions. So after erasing the marks or color-coded things I just did for coloring or underlining the values or formulas, I will erase it not to be confused with the other things I'm gonna write right now. And let's start by thinking the question. By thinking of how to approach this question. Our question is solve the cosine of x plus 3 pi 2 radian plus the cosine of x minus pi 2 radian is equal to 1. And again, solving means we have to solve for the input x that make this expression into 1. That means before we even think about the question, we have to combine them somehow by adding two terms. But again, we cannot just distribute the cosine. We cannot distribute the cosine to angle rotations, because while we're dealing with this kind of problem, with the simple or the basic operations we can apply to solve the questions such as real numbers, dealing with real numbers, won't work. That's why we need some indifference identities to solve this problem. So firstly, let's think about this separately. Let's think about what is the value for a cosine. What is the value for a cosine of x plus 3 pi over 2 radian first? After we solved cosine of x plus 3 pi over 2, then we will deal with cosine of x minus pi over 2 radian, add them, and think about the domain. So again, this is a cosine of x plus 3 pi over 2 radian, and if you're not familiar with it, just think about the x value as the alpha. Think about the 3 pi over 2 radian as the value beta. Then everything will gonna be simple. All you have to do is just apply the sum and sum formula for a cosine, because the two angle measurements, which are x and 3 pi over 2 radian, they are being added to form one angle rotations. So what is a formula for a cosine sum identity? That will be the cosine of the first angle. What is the first angle? Alpha times the sine, not sine but cosine of the second angle rotation, which is beta. All of that minus, because we're dealing with the sum identity for a cosine, the sine of the first angle rotation, which is alpha, times the sine of the second angle rotations on the unit circle, beta. All you have to do is simplify this value to solve for the answer. And what is the cosine of alpha in this case? The cosine of alpha will change into positive x. What is the cosine of beta? Cosine of beta will turn into 3 pi over 2 radian according to this question. What is alpha? That will be the x. What is beta again? That will be 3 pi over 2 radian. All we have to do is solve for this question. And just like we talked about in a previous video, and I'm going to go quicker, because this is kind of review what we've done so far from previous videos. And if you're not familiar with it, you need to go back to my previous video about what are the angle rotations, including the special angle, on the unit circle. What is the cosine of x? We don't know what the x is. We don't know what angle it is or which quadrant it lies on. So we will just write the cosine of x as the cosine of x, because we got no information for the angle rotation x. But we know what is the second one. So we have multiplied by the cosine of 3 pi over 2 radian. What is 3 pi over 2 radian in terms of degrees? That is 270 degrees, which is quadrantal angle, just like I explained in previous videos. And again, if you're not familiar with this concept, you need to go back to my previous videos and think about it more. So what is the cosine of 3 pi over 2 radian, which is cosine of 270 degrees? Well, if you remember it, that is equal to 0. And we have minus the sine of x, and again, we have no clue what the sine of x is. So we'll just write that term as the sine of x. Multiply by the second term, where the second term is the sine of 3 pi over 2 radian. We have any information what is 3 pi over 2 radian. That is 270 degrees. So we can figure out what is the sine of 270 degrees according to the knowledge we applied in our previous videos. That is equal to -1. So if we simplified, again, anything multiplied by 0, which is the fundamental operation, that is equal to 0. Minus sine of x times -1 will turn into negative sine of x. Negative sine of x. And according to the operation we learned, if it is negative and negative, that will cancel out as positive. So that will be positive sine of x. And this one is the simplifications for the cosine of x plus 3 pi over 2 radian, using the sum formula, sum identity for cosine. So we got the value sine of x. Now let's think about the second one, which is cosine of x minus pi over 2 radian, to combine the value with the cosine of x plus 3 pi over 2 radian. So the second value we're going to deal with is cosine of x minus pi over 2 radian. But there's something a little bit different with any kinds of things we deal with. Because normally we have 3 pi over 2 plus x as a standard form, but we have x minus pi over 2 radian. We cannot subtract the x, which is an unknown angle, by pi over 2 radian. So we have to fix this. We have to fix this in terms of standard form. And to deal with it, we have to drag the pi over 2 radian out as a positive. And it is being related by the negative sign. So what operation we have to apply? We have to apply the negative sign. So we have to make cosine of negative gets out, and we will have the pi over 2 radian, positive pi over 2 plus x. And what we're doing right now is we are trying to fix this term in terms of the standard form for a cosine. And the reason is because we cannot subtract the x, which is an unknown angle measured by pi over 2 radian. So we drag out the negative out and make a standard form as pi over 2 plus x. But now we have the x inside the angle rotations. So we have to think about how can we deal with this. But if you remember the property of cosine, the cosine is an even function. Just like I explained in the cosine's graph. Cosine of negative x, where we input the cosine, where we input the domain as the negative, that is same thing with saying the positive cosine of x. And I did a proof about this in a previous video about what are the types of angles on the unit circle. So cosine of negative x, the negative will go out and create cosine x. So we have just exact form as cosine of minus pi over 2 plus x. So using the cosine of minus x is equal to positive cosine x, now we can define it in this way. The negative goes out front and will create the cosine of pi over 2 radian. And we made a mistake here. It must be positive, it must be negative, because we dragged out the negative out from the positive x. So pi over 2 minus x will be our answer. And this will be the value, cosine of pi over 2 radian minus x. And the reason why we did is because we could apply the sum, the difference identity for a cosine of x minus pi over 2 radian. But it's always good for us to think of it as the standard form, like cosine of pi over 2 minus x. And the common mistakes is, before we start, again, we cannot distribute the cosine because the basic fundamental operation won't work in this case. So we have to use the identity. All you have to do is simplify cosine of pi over 2 minus x, where we're subtracting the unknown angle x from pi over 2. So we have to use the difference identities for a cosine, which is cosine of alpha minus beta is cosine alpha times the cosine beta plus the sine alpha times sine beta. So if you write the form, that will be the cosine of the first angle, pi over 2 radian, times the cosine of the second angle measurement. So let's put this down a little bit for spaces, and let's erase this color-coded mark. So we have the cosine of the second angle, which is positive x. And since we're dealing with the negative sign, which is difference identity, that will be plus sine of the first angle measurement. The sine of the first angle measurement is pi over 2 radian, times the sine of the second angle measurement, which is going to be x. All you have to do is simplify these values. And if you simplify, we will get the answer for a cosine of pi over 2 minus x. So we have to define what did I write here? This is just something that is not related to this. What is the cosine of pi over 2 radian? Well, we need to know that the cosine of pi over 2 radian, we have learned that from previous videos, pi over 2 radian is 90 degrees. And according to a lot of videos we have viewed so far, cosine of 90 degrees, that is equal to 0. Times we have cosine of x. We just have to write it as cosine of x because we don't know what the x is. We don't know what value it has, or we don't know which coordinate it lies on. So we just write it as the cosine of x, and we have plus the sine of pi over 2 radian. And again, pi over 2 radian is 90 degrees, where the sine of 90 degrees, we've learned it as the positive 1. Times we have the sine of x. So what we've done right now so far is that after converting the cosine of x minus pi over 2 into a standard form, now we define what is cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. And we got the value 0 times cosine x plus 1 times sine x using the difference form or difference identity for the cosine. And again, anything times 0 will be equal to 0. All we got is 0 plus 1 times sine x, which is equal to sine x. But what is our ultimate question? We have to know that our ultimate question was solve cosine x plus 3 pi over 2 plus cosine of x minus pi over 2 is equal to 1. So let's rewrite it. So we have to solve the cosine of x plus 3 pi over 2 radian plus cosine of x minus pi over 2 radian is equal to 1. But what was the cosine of x plus 3 pi over 2 radian? That value, we defined it as the positive sine x using the sum identity for the cosine. And for cosine of x minus pi over 2 radian, we also defined that value as the positive sine x. And we're adding those two values for sine, and we're getting the value as equal to 1. We have a like term as the sine x and the sine x. If we add the like terms and there are two of them, then there will be 2 times sine x simply. And that is equal to positive 1 according to our question. And our question is asking us to solve for the x, which is a domain or input that makes 2 times sine x as positive 1. So to solve for the x value, all we have to do is isolate it. So to isolate it, we have to divide by 2 to the both sides. So if we divide 2 to both sides, we'll get the sine of x is equal to 1 over 2. And the reason why we'll do this is now we have the sine x is equal to 1 over 2. And again, we have to solve for the x value that makes sine of x, the sine of x, which is the y value on the unit circle, as a 1 over 2. So we always have to think about when we're dealing with the sine, cosine, or tangent value, other than the graph, we have to think about it on the unit circle. And when we're trying to solve for the x value, that makes the sine x as 1 over 2. And we always have to remember that let's say there is any types of the angle rotations as the data. If you see that the random angle rotated on the unit circle, then we can express that angle using the coordinate for this point. That is the intersection with the terminal line and also the unit circle. Then the coordinate will obviously going to be x comma y because it is on the first quadrant of the unit circle, and also it is dealing with the positive and the y-axis on the coordinate plane. And we define the x simply as the cosine of the main angle theta, and y as the sine of the main angle theta. And this is how we define the cosine and sine. The cosine is the x-coordinate of the random angle on the unit circle, and sine theta will be the y value of that random angle on the unit circle. And using this information, we have to define the sine of x as 1 over 2. So in order to find what is the sine of x is equal to 1 over 2, we have to make a straight line for that 1 over 2. And let's say there is a line y is equal to 1 over 2. on the unit circle like this. And that means the point that has an intersection with the y is equal to 1/2, and the positive y-axis will be 1/2. And we always have to find the value that has an intersection with it, which is this point and this point. So in order to solve for that point and that point, we have to make a triangle. And by making a triangle, we will be able to know what is that angle rotation that created that y is equal to 1/2. And if you make a triangle, that will be the right triangle. And we're trying to look at the value where the y value is equal to 1/2. But we already know that that is a special angle that we already talked about. And that angle rotation will be pi over 6 radian. When it is pi over 6 radian, when the angle rotated pi over 6 radian, then the coordinate will be the positive cosine theta, which is square root of 3/2, comma 1/2, where the 1/2, where square root of 3/2 will be the cosine for pi over 6 radian, and 1/2 will be the sine for that main angle pi over 6 radian. So for that angle measurements pi over 6 radian, the first x value will be pi over 6 radian. But there is another angle rotation which is from the initial line all the way to this angle. And according to the property of the unit circle and the angle rotations on the unit circle, this angle rotation is same thing with the pi over 6 radian to satisfy the coordinate on the unit circle for the y sine value as 1/2. That means this angle is same thing with the pi over 6 radian. And if this angle is pi over 6 radian, then the whole angle will be from the pi radian, which is 180 degrees, that rotate the half of the circle or semicircle, minus the pi over 6 radian. So another for x value will be pi minus pi over 6 radian. And for pi minus pi over 6 radian, in order to subtract them, we have to have a common denominator. And we can fix the pi as 6 pi over 6 minus pi over 6 radian to actually simplify. We have 6 pi in the numerator minus pi over the denominator, or the common denominator, as positive 6. 6 pi minus pi will be positive 5 pi, and we have the denominator as 6. So we have the angle rotation as 5 pi over 6 radian. That means from here all the way to the initial line for the starting line, that will be the 5 pi over 6 radian. So the x value will be 5 pi over 6 radian. And we can go on and on and on as the angle rotates infinite direction, negative and positive direction. That's why we always have to visualize what is the domain restriction, which is the interval of 0 to 2 pi radian in this question. So for 0 to 2 pi radian, that means we're only thinking of the angle that is being included in one revolution of the unit circle. So that means 0 to 2 pi radian means as the angle rotates 360 degrees, like this,